Okay, now we'll proceed with our topic for today. So I'll include this topic as radio network coverage assessment. So this is a continuation ng previous part last time of the radio network access. No? Okay. So the topics I involved here is the connectivity challenges that we have, for example, for in different areas of the country, not only here in the Philippines but also in the other countries. And then we'll compare why we are choosing cellular connectivity versus WLAN or Wi-Fi. Because you see that the connectivity can be used for Wi-Fi. And then I'll show you some radio network simulation exercises that you can, so you can have more idea on how do we evaluate a certain area of giving or providing a network coverage. Okay. Okay, so let's move to the connectivity challenges again. No? So, so this was a previous slide as well that I have presented previously. So these are the connectivity challenges. So imagine an area where there are no coverage like this. So the lack of cellular coverage causes the following challenges. Number one is limited access in the remote areas. So we have encountered this especially during the pandemic, right? So if you don't have any coverage at all or mahina yung signal mo, you have a big problem. So it's quite frustrating. So especially there in these areas where they are already geographically isolated and digitally isolated, no? So it comes hand in hand sometimes. So malayo na sila sa kabihasnan, malayo pa, hindi pa sila connected sa internet. Okay. And this also includes the social connectivity issues. No? So people are having hard time to connect with their loved ones or friends, no, to get an update. Okay. And for emergency services accessibility, so there are areas that it may take them around more than 2 hours no before they reach the nearest hospital. So yung mga pag-attend sa mga emergency situations like this, so hindi siya matugunan na mas mabilis. And of course, the technological isolation. So we all know that yung pagkakaroon ng connectivity in a certain area also drives the economy nung area na yan. So for example, in the likes of our teachers, um they can do some remote lectures, right? If for example merong aberya sa isang area and then the only thing that you can deliver your lecture is remote. And of course, there are also, for example, for farmers or fishermen who wants to sell their goods online. Okay, they want to have a new client, so they can provide an online business in that area because merong connectivity. Okay, so these are the connectivity challenges. So what we're trying to do here in the Asia Open Academy is to have a use case and solutions that can augment the existing solutions. Okay, so we want to have this kind of use case, no? So we want to connect all of these isolated areas. Okay, so if we have some connection or connectivity in the area, so we can have the fixed wireless access. Okay, so Wi-Fi can be enabled. We have the IoT devices like the RX box. So the RX box is if you so you can have an idea what's an RX box, no? So an RX box looks like this, no? If you are connecting a certain device, this is an IoT device. So this is what an RX box looks like. So this is the one that our doctors to the barrios are carrying so that they can do some physical or medical assessment to the patients, no? So meron silang main unit and then the RX box is composed of a BP monitoring. Okay, so they can monitor yung blood pressure ng mga pasyente, ECG, okay, electrocardiogram, so yung sa puso naman yan, no? Pulse oximeter, so para makita yung oxygen content sa blood, temperature sensor, okay? Fetal heart monitor, okay? Ultrasound yan, so maternal tachometer, fetal movement marker, so para ma-check yung status ng baby, no, dun sa sinapupunan ng mama, nung mother niya. And then we have the garter belt and then yung power unit. So this RX box can be connected using Wi-Fi, 3G or LTE or Ethernet cable. Yan, pwede yan ma-connect. So the main issue is that once we have the patient's data, for example, nakita natin na okay, ito yung itsura ng baby dun sa sinapupunan ng mother. So we want to transmit that also, no, sa isang hospital or sa main hospital like PGH, and then we can have further assessment if there are existing problems, no. So merong isang kwento dito na uh, a young woman is pregnant, and then di niya alam na meron siyang mataas yung blood pressure niya. So using this RX box and with the help of our doctors to the barrio, nakita 'yon, and then naagapan 'yan. So they have saved another life dahil lang dito sa ating technology na 'yan. Okay. So to maximize this technology, we want to connect this, no, sa isang wireless connectivity. It could be a Wi-Fi or cellular connectivity, no. So that's why we are um, um, would like to help, no, on providing connectivity to connect this RX box, no, para makarating siya sa Philippine General Hospital, sa PGH. Okay, just imagine that kind of mission. And then, of course, aside from connecting IoT devices, the mobile access will be there, mobile internet, okay, and voice call. Okay, so this is one way of connecting this one. So you will be asking as well na what's the difference, no, of a cellular connectivity and a Wi-Fi connection? 'Di ba? Parang parehas ba 'yan? So most of the time tinatanong lagi yan, parehas ba yung frequency ng parehas ba yung LTE, 5G or Wi-Fi? Or ang Wi-Fi ba is 5G, 'di ba? So minsan merong confusion about that one. So I prepared one slide to compare, no, anong pagkakaiba nitong cellular connectivity like 2G, okay, 3G, and 4G or 5G, and then yung Wi-Fi. Okay? So here makikita nyo dito yung um, sa left side, no, yung connectivity ng cellular. Okay, ayusin ko lang ng konti, no, ng cellular at ng Wi-Fi, no. Yan. So para at least tama yung natin. Yan. Wi-Fi versus Wi-Fi versus cellular connectivity para alam natin ano yung pagkakaiba nila. And then why we are choosing, no, cellular connectivity, although we can also use Wi-Fi, no. Okay. So on the left side you will see yung Wi-Fi, and then on the right side you will see the 2G, 3G, and 5G. These are the cellular connectivity, right? Okay. So can you see the screen? Okay. So first pag-usapan natin is the frequency. Okay, so ito yung frequency natin. Okay, so most of the cellular frequencies or wireless connectivity frequencies pinag-usapan natin the last time. So it ranges from 450 megahertz up to 71,000 megahertz. That is 71 gigahertz. Okay. Okay, so when we talk about WLAN, meaning of WLAN, no, wireless local area network. So it refers to a wireless networks that provide connectivity within a limited area. Okay, so most of the time yung mga Wi-Fi's natin is short range yan, mga short coverage yan. Unang-una, ang driver niyan is the power. Okay, mahina yung power niyan. And then next is yung frequency. Okay, yung frequency na ginagamit niyan. So compared sa ating cellular connectivity, it's wide and long coverage. So it reach up to from 1 kilometer up to 5 kilometers. So ganun kalayo yun. Just imagine the difference ng coverage niyan. Wi-Fi, pag lumabas ka lang ng bahay mo, putol na yung ano mo, connection mo. So it does not goes up to 100 meters. But there are applications, no? Ng Wi-Fi based on the solutions that they created. But most of the Wi-Fi that we have seen is lalo na yung mga ini-install sa bahay natin are short range or short coverage Wi-Fis. Okay? So these are the Wi-Fis are being used sa home, sa school or office building. Okay? So, typical ang pinaka ano natin dito pag when we say Wi-Fi, it's a network based on IEEE 802.11 standard. Okay? So, ang pinaka broader term na talaga natin diyan is the WLAN. Okay? It's a broader term that encompasses any local wireless network. Okay? Okay? So, this is the standards niyan. So, ang standard na ginagamit niyan is 802.11 and then ang 2G, 3G, 4G or 5G uses a cellular standard like GSM, UMTS, LTE and 5G. So, ito yung pagkakaiba ng mga yan, no? And yung mga standards ng mga yan is galing from 3GPP. So, magkaiba sila basically ng standard na ginagamit. Okay? Next is it uses free spectrum. Okay, so si Wi-Fi uses free spectrum, no? So si Wi-Fi, ang most na ginagamit niyan ay less than meron tayong mga Wi-Fi that is less than 1,000 megahertz. Ito yung mga 900 megahertz, ang tawag natin is Wi-Fi Halo. So ito yung panlaban ng Wi-Fi sa mga ano no, sa for outdoor connectivity, but we haven't seen it yet no, na implement. So Wi-Fi Halo yung ano, yung pang ano diyan, isa sa mga tingin diyan. But it uses a free spectrum. And then meron tayong 2.4 megahertz, isa sa mga sikat na Wi-Fi frequency. Okay? And then meron tayong 5 gigahertz. So sometimes na napagkakamalang 5G. Okay, kasi ang frequency niya is nasa 5 gigahertz. So minsan nasasabi nila, 5G yan kasi 5 gigahertz ano. But does not necessarily mean na 5 gigahertz is a 5G technology. So gumagamit lang siya ng 5,000 megahertz na frequency. And you will see, habang maliit yung ating frequency, mas lumalayo yung coverage niyan. So kapag gumagamit tayo ng 5,000 megahertz o 5 gigahertz, maliit lang yung coverage niya, no? Dahil sa propagation loss ng frequency niya. Kaya kapag ito ginagamit mo, dapat medyo malapit ka doon sa Wi-Fi, no? Para ma-maximize mo yung capacity ng Wi-Fi. Ang kagandahan naman ng 5 GHz, medyo malaki yung bandwidth dito. So, pag-usapan ulit natin yung kalsada, medyo malapad yung kalsada dyan. So, mas malaki yung traffic na makakadaan. Kaya kapag ginamit mo yung 5 GHz, pag gagamit ka ng Wi-Fi, kung meron namang 5 GHz doon at maganda yung signal at quality, use the 5 GHz. Kasi mas mabilis talaga doon. Kasi mas malapad yung kalsada doon. Compared sa 2.4. Okay, sa 2.4 medyo maliit lang yung mga ano diyan, mga frequency diyan, mga bandwidth. Okay, and most of the madaming interference. Okay? So ito yung difference niya, no. So meron tayong tatlong major frequencies sa Wi-Fi. However, sa 2G, 3G, 4G and 5G, ang dami nating frequencies. Okay, so meron tayong 450, 700 megahertz, 900, 1800, 21, 26, 35 and 71, no, up to 71. But these frequencies are are dedicated spectrum to each operator. So meaning yung mga operators natin dito sa Pilipinas, they are paying to have this frequency dedicated for their subscribers. For example, merong frequency ng 900 si Globe. So meron siyang dedicated na frequency. And that frequency cannot be used by Smart or Dito because that one is dedicated sa isang operator lang, no? So meaning hindi tayo pwede mag-overlap. Unlike sa Wi-Fi, you don't have any control dun sa kung sino man yung gagamit nung frequency natin because this is a free frequency. Everybody can use it. Okay? So you cannot complain na merong interference or mataas yung interference dahil merong isang entity na gumagamit ng 2.4. Okay? So yun yung isa sa mga advantages ng cellular connectivity. So in terms of the quality ng spectrum, the quality of the spectrum here is better. And then you have full control. Okay? But this one, of course, if you are the only one using the Wi-Fi, it's on your benefit, no? Wala kang kaagaw sa frequency. But kapag may dumating na panibagong player and then they use 5 gigahertz or 2.4 gigahertz, you have to you have to deal with the interference. So this is short range, so typically up to 100 meters lalo na sa indoors, sa Wi-Fi, okay? And the coverage of this is from 2G, 3G, 4G and 5G goes with kilometers, no? Thousands of meters compared sa Wi-Fi natin. Okay, so later makikita niyo kung paano siya gumagana, no? Okay. And the next is limited mobility support. Yan. So most of the time, no, limited talaga yung mobility unless talagang connected yung mga access points. Okay? Ang problema niya kapag lumabas ka ng building or ng airport, putol na yung Wi-Fi mo, right? Unlike sa 2G, 3G, 4G or 5G, there is a high mobility support. So meaning, there are engineers that are optimizing this seamless mobility and coverage. Anong ibig sabihin nun, no? For example, you're inside the mall and then connected ka sa 4G or 5G. When you go outside the mall, di nawawala yung signal mo, right? Nagiging ano ka pa rin. Natatransfer ka from one signal to another signal. So from indoor going to outdoor. So meron tayong seamless mobility. Unlike Wi-Fi, okay, pagka lumabas ka ng building, putol na yung ano mo. Putol na yung connectivity mo. So ang mangyayari, isi-shift ka ng mobile mo to a cellular connectivity. Okay, so yun ang kagandahan lang. Meron tayong working or interconnections, no? Na ano siya, no? Interworking yung dalawa. Pero that is happening in the urban area. But what will happen if you're in a rural area, no? Nung pinag-usapan natin kanina. So, for example, doon lang sa clinic or doon lang sa barangay merong Wi-Fi. Pag umalis ka sa vicinity of the barangay, your Wi-Fi or internet connection will drop. Okay, and then you'll go back again to a cellular connectivity. So if there's no cellular connectivity in the area, so your data connectivity will be lost. Okay, are you getting my point? So yun yung ano niya, yun yung trade-off niya, no? That's why if there's a cellular connectivity in the area and then you're connected via via 2G, 3G, 4G, so if you're within the coverage area of of uh, of one cellular coverage like this, so hindi mawawala yung ano mo, hindi mawawala yung signal mo. Okay? Yeah, that's one of the benefits. No? Yan. Yeah, syempre, Wi-Fi is easy to access and connect in local areas. Okay? Yeah, especially from building A, airports, okay, barangay, health centers. Yan. So, kung meron silang Wi-Fi dyan, tatanong mo lang, meron po ba kayong Wi-Fi? Yan. Okay. Next is a wide accessibility anywhere with network coverage. Yan. So, sabi ko ngayon, basta nasa network coverage ka ng isang area, so you are ensured that you have sufficient network coverage. Okay? And of course, most importantly, yung kanya sinasabi ko kanina, yung prone to interference from other devices and networks. Okay? And this one is less prone to local interference because the operators have dedicated frequency on that one. Okay? So hindi sila pwedeng ano yan, hindi pwedeng gamitin ng iba na hindi lisensyado. Okay? Ayan. So ito yung major na pagkakaiba ng WLAN or Wi-Fi versus cellular connectivity. Okay? Ayan. Alright. So now, nabanggit natin kanina, no? So we have a wide and long coverage. How wide, sir? No? Gaano kalayo ang nararating ng isang cellular connectivity? And how do engineers or radio access network engineers define the coverage and yung extent ng coverage ng isang cell site? For example, mayroong isang barangay nangangailangan ng coverage. How do we know, no? How many cell sites are needed to cover a certain area? Okay, are you thinking that too? Paano nangyayari 'yon? So paano niyo na-assess na isang cell site lang kaya, no? Isang cell site lang 'yan, no? Dalawang cell site kailangan natin diyan. So we are using a specific tool, no? Ang tawag natin diyan is the simulation tool, which you are about to see, no? Pero before we do that, let's have a brief ano muna, no? A brief orientation. What are the different types of ano, no? Nung mga cell site, no? So yung mga cell sites natin ay iba-iba ang itsura niyan, di ba? So meron tayong ganito, meron tayong four-legged na cell site, okay? Okay, meron tayong eto pala. Meron tayong four-legged na cell sites. Ito katulad nito. Okay, so maraming laman 'yan. So ang tawag natin dito ay mga microwave antennas. Okay? So most of the time kapag mga important locations, ang mga nandiyan malaki yung capacity, ganyan ang ginagamit nating tower. Meron tayong mga cell sites like this, which you can see in the urban areas. Meaning limited yung mga pagkatayuan natin ng cell site na to. And then most of the location or areas are populated by buildings, no? Kaya ang ginagawa natin, instead of building a tower, we are putting the antennas on top of the rooftop. Ayan. On the rooftop pala. On top of the rooftop pa. On the rooftop. No? Ayan. So ang tawag dito is mga rooftop antennas. And then there are areas that we call it the end site, no? Meaning sila na yung pinakadulo ng network. So if they are the end site, so we don't need a tower like this that can support a lot of equipment. So we just use a simple or a low load type of tower which we can just put a few number of antennas. Yan. So meron tong cost implication. Of course, yung mga civil engineers ginagamit din yan to assess because there are certain areas in the Philippines na malapit sa dagat and bagyuhin, no? Meaning nasa typhoon belt. No? Madalas binabagyo yung lugar na yon. So they need to design a specific tower that can withstand 100 to 200 kilometer speed ng ng wind. So kaya minsan may makikita kayo na yung mga towers natin na nasa tabing dagat are like this, lalo na kapag binabagyo. Okay? And then you will also see a cell site like this na dinideploy natin. For example, merong event dun sa area. Like for example, nung bagong Pilipinas event sa Quirino Grandstand, they put a cow, no? A cell site on wheels like this para mag-support ng additional capacity. So this is intended to have additional capacity. But in some cases, they put a cow like this to provide additional coverage. For example, meron tayong event and then walang signal doon ng LTE. So they will put a cow or a cell site on wheels that have an LTE cell site, no? Para at least makover natin yung area. Meron din tayong mga cell site like this, a monopole cell site. Okay? So mas tipid to sa space. Okay? So especially if you want to have a strong tower that has limited space, yan. So gumagamit tayo ng monopole. So para to mga poste ng Meralco. Okay? And there are also cell sites like this you will see in other countries and here also in the Philippines. We call it the camouflage cell sites, no, or mga SWAT sites sa terminology ng Pilipinas. So we use this kind of deployment to have an aesthetic view, no, meaning there are certain private entities like resorts, okay, hotels that they don't want to disrupt, no, yung aesthetic feature ng building or ng resort. That's why we are camouflaging, no? Bine-blend natin yung ating cell site based on sa surroundings natin. Okay, so we call it the camouflage. Okay? Hindi namumunga to, no? Pwede rin natin lagyan ng bunga pero hindi natin maiinom yung buko sa loob. Okay. All right. So next is the wall mount antennas. So when you go in Makati or Cebu or Davao na merong mga matataas na buildings. Okay? So instead of building cell sites, we install these antennas sa gilid ng mga buildings. Okay? So just to maximize yung building and then to give sufficient height do sa mga antennas natin to give us a better coverage. Okay? So, putting a cell site like this needs a local knowledge. Yeah, local knowledge. What do we say local knowledge? Ibig sabihin yung engineer or yung professional that doing the design has local knowledge about the area. Alam niya na this area ay maraming buildings, okay? And then itong mga buildings na to ay ganitong structure, okay? Dito sa lugar na to is mabundok and meron tayong mga blocking. So ayan, no. So ito yung mga knowledge na kinakailangan natin, no? Okay, kaya as much as possible yung mga radio access network engineers, they are getting familiar do sa area, before they deploy a cell site. Okay, that's why we are doing what is so called the site survey. Okay, so yung site survey, ang isa sa mga isa sa mga objective is to get familiar sa area. Okay, so you will see it on the map. Mamaya makita nyo, no? How do we assess it? And then going in there to have an actual ocular inspection para makita natin kung feasible ba talaga, no, na magtayo dun, ng cell site dun sa area. Okay? And of course, you will hear the term private cell sites or private networks. So nagde-deploy na rin ito sa ibang bansa. Especially for those factories na gusto nilang gawing connectivity ay 5G instead of Wi-Fi. Okay, so they choose 5G connection instead of sa Wi-Fi. No? So they are using this kind of cell site. Ang tawag natin dyan is private network. And sometimes ang ginagawa natin dyan, instead of this sa loob ng network, pwede rin natin siyang i-deploy dun sa mga areas na may mga disaster or mga emergency situations. Imagine these are easy to carry. Mabilis lang dali niyan. Pwede mo yung ilagay sa likod ng isang 4x4 na Ranger or Raptor. Okay? Lagay mo lang sa likod diyan and then buhay mo, i-connect mo sa Starlink, mabubuhay na yung cell site. Okay, you can give coverage immediately on that certain area. So ganun kabilis, no, yung deployment. Just compare dito, matagal to i-build, no? Matagal i-build 'yan. Compared dito na pwede natin dalhin. Ito naman, pwede natin siyang dalhin but you need a parking lot, no? For this one, sufficient parking lot for this one. But this one, ilagay mo lang sa likod ng ano 'yan, ng 4x4. And then meron kang maliit na, for example, 2x2 meter, pwede mo na siyang install. So ganun ka bilis, no? It depends sa application na gusto nating gawin, no, dito sa sa deployment ng cell site. Okay, so ito yung mga different applications sa labas, no. And then pagka tinignan naman natin sa loob ng mga ng mga buildings, okay, meron tayong ground floor and then or second floor, naglalagay din tayo ng mga cell sites diyan. So yung mga equipment na ginagamit natin from outdoor, we can also use that sa mga indoors. So what we can do is that we just put it inside or inside the basement or minsan nasa roof deck yung mga equipment natin. So nandun yung battery unit, cabinet, mga baseband natin, radio unit. But instead of using an antenna, a panel antenna like this, yung nakikita niyo mga panel antennas na to, yung mga ganyan mahaba, okay, na mga puti, we are using a specific type of antenna. No? Ang tawag natin dito ay distributed antenna system. So when we say distributed antenna system, ito yon yung mga antenna kulay puti na nakikita niyo sa loob ng mall. So when you go inside the mall, pag pumunta po kayo diyan, nakikita niyo itong mga antenna to. Yan. Ito mga bilog na to. Yan. These are omnidirectional antennas. So but in this type of antenna, we call it the active antenna unit, no. So small cells ang tawag natin diyan. Hindi po yan Wi-Fi access point. So that is an active antenna or a distributed antenna, no? Or an omnidirectional antenna from a cell site. There are small cells that are activated with Wi-Fi inbuilt na yung Wi-Fi and 3 and 4G and LTE, no. But most of the time kapag nakakita kayo ng mga antennas like yung nasa indoor natin, itong mga building na to. Yan. So we call it the omnidirectional antennas. Okay, mga antennas po yan, nagbibigay ng signal. So don't be surprised kapag sa isang building, lalo na nasa probinsya kayo, pagpasok mo sa isang building, wala kayong signal, no? And then wala kayong nakikita mga kulay puti na yan. Ibig sabihin, wala siyang in-building solution. Wala siyang cell site sa loob ng building. Umaasa lang yung building sa coverage galing sa labas. Okay? So we are praying na it will penetrate inside the building. Okay? But most of the important buildings or mga populated buildings natin or infrastructures, malls, meron tayong mga tinatawag na IBS. Okay? So nilalagay natin yan, so dinidistribute natin yung mga antennas natin sa loob para magkaroon tayo ng signal. Okay? Ayan. So may mga makikita naman kayong mga antennas like this, mga parihaba na kulay na ano no, na square or rectangle or square na kulay puti or grayish white. Ang tawag naman natin diyan is mga indoor na directional antennas. So para naman to ma-focus natin no, yung ating mga antenna sa loob para ma-contain natin. So we don't want any spillage naman sa labas. Okay? So this is how we control yung signal natin sa loob ng ano ng site. So typical kapag ginagawa natin yung plano niya, meron tayong ano no, meron tayong ginagawang planning diyan. So these are the indoor coverage, okay? Planning. So naglalagay tayo niyan to ensure that our subscribers will have good coverage and high quality and sufficient capacity no for with optimal cost of implementation. So typical naglalagay tayo ng ganito no. So ina-assess natin yung floor plan. So tinitingnan natin nasaan yung mga possible locations ng mga subscribers. Okay? Nasaan sila? For example, meron tayong parking dito. So if they want to stay in the parking area or pagpasok nila sa parking area, meron ba silang signal or wala? So we are providing this type of antennas no. So you can see here, these antennas can also be planned using a Wi-Fi. No? So a mobile network operator can choose if they can provide Wi-Fi coverage plus um, ano no cellular connectivity. So in this case, naglagay tayo ng mga tinignan natin saan natin pwede ilagay yung mga antennas na yan. Okay? So hindi siya basta-basta nilalagay no. Pinaplano po ito. We are planning here, for example, we know that there are, so based from the information coming from the building admin, that there are employees here. Okay, meron tayong mga employees dito. Okay, and then marami tayong mga taong nandito, no, pumupunta dito, nag-aabang ng elevator, okay, papunta or paakyat ng escalator. And then after that, we do the simulation. Yan. So tinitingnan natin ano yung magiging itsura ng coverage natin. Okay, so this is how we do the simulations no para makita natin magiging maganda yung signal. Okay, so this is what we call the indoor building solution. Okay, so nakikita natin what would be the impact of that coverage of that solution inside the building. Okay, kaya kapag nakakita po kayo ng mga ganyan, makikita niyo na oy maganda yung signal dito. Malakas yung signal dito. Okay? So ito yung sa indoor coverage no. So, papaano naman kapag mga outdoor areas, no? For example, itong mga areas na to, mga malalaking lugar na ganyan. So, it's difficult to put a Wi-Fi here, right? So, have you imagined how can we cover this with a Wi-Fi? How many Wi-Fi access points do we need, right? So, sa isang bahay lang, there's a possibility na isang Wi-Fi na yan, no? Pero if you see this, there's a lot of people with the different households, no? Marami tayong mga lugar na i-cover. Although we can augment this with Wi-Fi connections, right? So we can have a fiber optic na meron tayong distribution point dito and then we will distribute the fiber optic. But yeah, you can see, no, yung implementation and then yung cost din nun is malaki, no? But if you want to provide immediate cellular coverage para lang sa mga basic texting, no? Yung SMS, text, voice call, short, small data like Viber, WhatsApp, Messenger, which is very important na, no? So, hindi mo siya po-consume ng 100 Mbps or 50 Mbps, right? So, a 1 gigabit or 1 gigabyte or 2 gigabyte data plan would suffice, no? Per month, pwede na. So, we don't need a Wi-Fi na dyan. No? Pero kinakailangan, meron lang tayong coverage dyan. So what we initially do is, yeah, we build the cell site, no? Yan. So andito yung mga cell site natin. Okay. So nagbi-build tayo ng cell site dito. So kapag tinignan natin yung cell site natin, dyan yung radio access network natin, you will see ano yung mga different parts of our cell site, no? So balikan natin ulit yun, ano? Balikan ulit natin. So kanina nakita nyo, meron tayong tower, okay? Meron tayong tower or structure. So it depends dun sa location. So during the planning stage, dinidesign niya, no? Or ina-agree yan with the civil engineer also and transmission engineer and yung RF engineer. Anong type of tower ang gagawin natin? So nakita nyo kanina sa previous examples, we have a four-legged, we have an SST, we have a guide tower, we have a monopole, we have a rooftop, okay? We can have a wall mount type of cell site. So that is being decided during sa planning stage. And then we use this tower structure to put those panel antennas. Okay, so these are what we call the panel antennas. Yung nakita niyo pong kulay puti or grayish white dun sa area. And then after that, we have this, we have the low band and the high band. So frequency yan. So just imagine it's like an AM and FM radio. Okay, para dun po sa mga hindi masyadong technical. So just consider it as like a AM and FM radio. So AM radio yung mga 900 megahertz and then FM radio is 1800 megahertz. So para makapag-distribute tayo ng signal. Okay, para marinig natin yung mga makakausap natin, makatransmit din tayo. So ito yung parts. So ito yung ating radio unit. May mga remote radio unit tayong nilalagay dyan. So dito nanggagaling yung signal natin. And then connected yan ng jumper cable. Okay, meron tayong jumper cables. And then we have what we call the common public radio interface or fiber optic cable connected yan sa ating baseband unit. So the baseband unit, you can think of it as a central processing unit, no? Or yung CPU ng ating mga computers. So this is the one that processes yung mga baseband signals natin. And ito naman yung nagka-translate papunta ng electromagnetic energy, no? Tapos itong mga antennas na to, sila yung magdi-distribute or magpo-propagate kung gaano kalayo yung mararating ng ating mga antennas. Okay? Ano mga ating mga signal. So yung ating processor na or baseband unit, lalagay natin yan sa isang enclosure. Okay, nandiyan yung rack natin. So nandito yung power niyan, okay? Nandiyan yung backup battery niyan. So most of the time yung backup battery can last up to 4 hours, okay? Meron tayong ventilation, nandiyan yung fan para hindi siya mag-init. Or in some cases, kung wala nito, nasa loob ng isang cabin. Okay? Nasa loob siya ng isang cabin which has air conditioning, no? So meron siyang dalawa air condition na tumatakbo, no? Nagpapalitan ng takbo para mapalamig natin equipment. And then after that, meron tayong microwave antenna. Yan, papunta ng core network natin. Yan, so once we have that already, meron tayong connectivity, no? We can connect yung mga RX box, okay? Yung ating mga mobile phones and other equipment, no? Pwede natin mai-connect. So this is how yung mga RAN components, no, nilalagay natin. So we build this type of radio access network, no, component. Yan. So after natin ma-build yan, what we do is we do the simulation. So sinisimulate po natin, no? Yan. So once we do simulation, we can predict, no? So parang mga nasa pag-asa, no? So ang Maynila ay magkakaroon ng manakanaka at pabugso-bugsong signal level ng 2G, 3G, 4G at 5G. Ayan, parang ganun po, no? So nagkakaroon tayo ng prediction or simulation. So nalalaman natin we can estimate, no, where is the possibility of having a good signal and a bad signal. And then that's the reason why we are still proposing another cell site on a certain location. Right? So this is color coded, no? So when we see a color like this, for example, yung mga dark blue na nakikita nyo dyan. So this is a full bar, deep indoor. So what does it mean? So imagine you're inside your house and then you look at your phone, full bar ka. So you have a full bar. Meron kang of 5 bars, no? Full bars. Yeah, ayun yung negative 75 dBm. Ito naman is deep indoor, no? Meaning kahit pumasok ka sa loob ng CR mo. Okay, pumasok ka sa loob ng kwarto mo, full bar ka. Ayan, ayun ang ibig sabihin niyan. Ito naman ay full bar indoor, okay? Nasa sala ka, you are in the living room, you have full bar. But once you go inside your bedroom or inside the comfort room, it goes down to 4 bars or 3 bars. So that is what is the meaning of the full bar indoor. Okay? So ito yung mga kulay na yan. Okay. Next we have this light blue, a full bar outdoor. So you don't have a full bar indoor, but when you go outside your house, so you will get 5 bars, no? Full bars ka sa labas. So that is the meaning yung full bar outdoor. And then itong kulay na to, yung ating yellows is 2 to 3 bars outdoor. Okay? So nasa labas ka ng bahay, meron kang 2 to 3 bars outdoor. Ito namang orange is 1 bar outdoor. Okay, nasa labas ka na ng bahay pero 1 bar ka pa rin. And then itong red, when you see a red, meaning incidental to no signal. What does it mean when you say incidental to no signal? Incidental means wala kang signal and then suddenly meron bigla 1 bar. Gumalaw ka ng konti, you move a little bit and then you will have 1 bar. And then galaw ka ng konti, you have 1 bar. That's why in the previous days of cellular communications here in the Philippines, you will hear people climbing on a tree, okay, umaakyat sa rooftop, okay, so that's to get the reception they need. So that's what we call the incidental signal, no? Okay, so that's the how we use it, no? So now, how do we use this kind of simulation? So I will show you a typical example, no, of how we do it. So that, for example, you have a project in your area or probably in your school, and you want your students to learn also the planning in the radio access network, okay? And eventually when Open RAN comes in and then you want to have an Open RAN deployment in your area, so you know how to initially assess, no? Do you really need additional cell site in your area or not, no? So I'll show you a typical example of a planning tool. So this planning tool is a simplified planning tool, no? Yeah. So we call it the Radio Planner 2.1. So yung mga operators natin are using a more sophisticated and more advanced planning tool. So that is using an updated satellite map, okay, an updated clutter maps, and a very precise and accurate simulation, no? Meaning up to 5 meter ang kanyang resolution, no? Meaning, and the 5 by 5 meter, they can readily say you have a signal and you don't have a signal like that, no? But this one, I'm using a 50 meter, 1 kilometer resolution map. So it's not so accurate like the one that we have with the operator. But we can use it as a initial assessment tool, no, to have what we have, to assess, no, yung mga signal levels. So provided we have an area here, no, so this is an area, a typical area that I have chosen to show the different clutters. So initially what we want to know before we do it is we need to be familiar with the place. Okay, so this is what I'm saying as a local knowledge, no? So especially if you're living nearby, so you will have a local knowledge on the area. So for example, here is a part of Laguna Lake, so where I live nearby, no. So malapit lang ako diyan sa ano. Andito ako sa may malapit sa dagat, no. So you know, no, that there's a lake here. So this is the Laguna Lake. Okay? So this is the Laguna Lake. So alisin muna natin yung simulation na yan. So meron tayong Laguna Lake dito. And then you can see that there's a lot of houses here sa gilid. Okay? So we want to check, no, what will be the signal coverage, no, if we will deploy, for example, an LTE 900 megahertz. And so that is our exercise for this session. No? So first, we need to check. No, we need to have a requirement from a customer, from the business team that we need a cell site in this area. Okay, we need the cell site in this area. Okay, if provided we are a new operator and then we want to build a new cell site in the area, right? So for us to build this, for example, we want to cover this area with one cell site, no? So let's try to check the parameters. Okay, so in each cell site, you will set a parameter. So for example, if you click this one, you will have a name, no? So every cell site has a name. Okay? So that's good. Hindi lang yung mga pets natin ang may name, no? Every cell site has a name. So typical naming convention of a cell site depends on the location. Okay, so that is easier for the engineers to pinpoint where is the location. For example, BGC site, BGC High Street. So we know that there is a cell site inside the BGC High Street. For example, Canlalay San Pedro site. So we know that the cell site is located within Barangay Canlalay inside San Pedro in Laguna. Okay? So for example, Rizal Legazpi cell site. So Rizal Legazpi is the cell site is approximately located in Rizal Avenue in Legazpi City, Albay. Okay, so initially you will have an immediate idea where the cell site is located. Okay, so that's why we are having a naming convention when using a cell site. So in this one, we will not use that. Okay, so we'll just use an IORA 1. No? So maybe it's the first cell site that will be built using an open run for IORA like this. And then after that, you will have a coordinates. Yeah. So we're not only putting, for example, cell site beside Mang Juan's barong-barong. No, it's not like that. So we need to put an exact coordinates. So the coordinates is latitude and the longitude. So the latitude are the grid lines, no, you can see in the map. Yeah. And then the longitude is 121.12.001. Okay, so we know exactly that this cell site, this is the precise location or the accurate location of a cell site. Okay. Now, after that, we will have, so we already know where the cell sites is located, no? We will be put, no? So we will have 3 sectors. So now let's go back, no? What are these 3 sectors, no? What are these 3 sectors? So the 3 sectors, just imagine this one. So these are the 3 sectors. So we have the sector 1, the sector 2, the sector 3. You have the sector 1, the sector 2, and the sector 3. So sector 1 is the one that is pointing near the north. From north clockwise, that is the sector 1. Okay. So going back to this simulation, so this is the sector 1. Okay. So we have the sector 1 parameter. So if you go to the sector 1 parameter, we can call it IORA 1, no? So meaning sector 1 of IORA 1. Okay? So you have this one. So meron tayong parameter dyan ng antennas. Okay? And then you can also plan a frequency channel group. Okay? So anong channel? Is it channel 2, channel 3, channel 4, channel 5? No? And then what is the transmit power? So in this example, we will be using an LTE 900 with the 20 megahertz, no? So we will use a 0.03 watts. Yan. 0.03 watts yung power ng RSRP natin. Yung ating LTE power. Okay? And then this one is 900. So this an eNode B 900. Okay? eNode B 900. 900. So it's a naming convention. So meron tayong cable. So you can choose a cable. Okay? So remember yung cable ng antenna going to the radio. So that is the cable. So this antenna, this cable from connecting this antenna going to this radio. So ganun ka step by step yung ano no, the detail no, yung paggagawa natin ng simulation. So you have the cable, so we will be using a cable. So in this example, we will be using a jumper cable coming from Andrew, which is LDF050A. So based on the specification. And yung jumper cable natin could be 2 meters lang. Okay, so ibig sabihin from this cable, from this antenna going to this radio is 2 meters lang. That's why we are using 2 meters. Okay, and then we'll put additional loss. Okay, so that is 0.5. And then how high is our antenna? Yeah, so we will just see how high is the antenna. So when we are measuring how high is the antenna, we call it the above center line. No? So we are selecting the center of the antenna going down to the ground. So ito yung antenna height natin. If you are using this antenna from the center of the antenna going to the ground. Okay? So hindi yung dulo ng antenna, hindi yung tataas ng antenna. So yung gitna, no? So the center line. So we go for the center line. So we just want to build around 30-meter tower. Okay, 30-meter antenna. And then if we use a gain of, for example, 18 dBi gain. So this is a parameter of an antenna, no? Okay. And then the azimuth. Okay, the azimuth is what is the orientation of the antenna, no? What is the orientation of the antenna? So is it pointing to um, to 0 degrees, okay? Or pointing to 90 degrees or pointing to 180 degrees. So meaning, saan nakatutok yung antenna yon? So dito, nakatutok siya sa 0 degree. Okay? So meron tayo ditong orientation ng antenna. So kapag pinaplot natin yan, okay, so just let me do some annotation. Yan. So imagine you have a circle like this. Okay? And then hatiin mo yung quadrant mo. Okay, hatiin mo siya. So this is 0 degree. This is 90 degrees. This is 180 degree. Okay? And then this is 270 degree. Okay? So yung antenna orientation natin is nakaturo dito sa 0 degree. Okay? And then another antenna will be pointing here at 120 degrees and another antenna pointing here. Okay? By 240 degrees. Okay? So that is what meant by antenna azimuth. Okay, so we are pointing saan nakatutok yung antenna natin. So that is very important because if you are targeting something, kung saan mo ikakabit or saan mo, ano yung what specific area would you like to cover, so you need to pan the antenna. So imagine the time when you are watching a television and then your father asks you to go on the roof to pan the antenna. Okay, ikot mo yung antenna, no? Yan. So you don't have this ano, no? You don't have this you also use this kind of tuning of antenna, no? Hindi lang yung tatay mo nag-uutos sa'yo, boss mo lang. Okay, so um the orientation ng antenna, no? And then you can select what type of antenna model are you using, no? Anong type of model? So maraming model ng antenna, no? So it depends on the specification and the type of application that you want. Okay, so here, no, ito na yung ating parameter. Yan. So what we will do, we will just repeat that, no, into another one. So this one, we will use it IORA 12.03, and then this is 30 meters. Okay, and then this is 2 meters. So tandaan nyo lang yung mga parameters natin kanina. Okay, and then this is 18 dBi. Okay, and then on the other hand, we'll go to IORA 3, IORA 1.3, third sector. Okay, and this is 2 meters. And this is 30 meters. So pare-pareha silang 30 meters with 18 dBi na and then this one is 240. So nakatutok dito. Okay? Ayan. Okay, so ito na yung ating ano, no? Ito na yung IORA 1 natin. Okay, IORA 1. So gagawin natin, pabubugahin natin si IORA 1, no? Ayan. So titingnan natin hanggang saan yung maaabot ni IORA 1. So when we look at that. So makikita nyo, no, ang distance itong dalawang to, if you check the distance of these two, is around 4.5 kilometers. No? Aerial distance yan. Okay, 4.5 kilometers. So from this point, we can do the calculation. Okay, pagka sinimulate natin yan, yan. So this how the signal level looks like. No? Yan. So makikita nyo dyan, hindi siya um, um, parehas, no? So yung mga tumatama sa tubig ng Laguna Lake is going smoothly, malayo, no? So para kasi siyang ilaw, no? Nagre-reflect yan sa tubig, no? Kaya wala rin tayong obstructions, kaya yung flow ng signal is smooth, no? Dire-diretso. Okay? So sometimes we can maximize this kind of phenomenon, but most of the time we don't want this kind of phenomenon because it will cause some interference and uncontrollable scenarios in handling the radio frequencies, no? Okay? So makita natin na in this area, it's not yet so sufficient, no? Hindi siya masyadong sufficient kasi may mga areas tayo dito na hindi pa natin ma-cover. Okay? Are you getting this one? Okay, so nakita natin, no? So this one is nag-simulate lang tayo using in a 5 kilometer. If we extend this further to 10 kilometers, you will see na may mga areas na tayo dito na hindi siya mag-aano, hindi siya um hindi siya hold on, titingnan lang natin yung ating unit of measurement. Ayan, no? So ito yung ating signal level. So medyo mahina pa siya, no? So malapit lang yung signal natin kasi we are using a 900 megahertz and then an LTE signal. So we can assess already, no, na yung signal natin with 10 meter, ang height natin na ginamit dito is 30 meters. Okay, we use a 30 meter tower here. So ito yung signal level ng 30 meters. Now, what will happen, sir, if we change the antenna height? Okay, so ginamit natin 30 meters. If we use, for example, 50 meters. Okay, so ginamit natin, tinaas natin yung antenna natin into 50 meters. Okay, nag 50 meters tayo. Yan. Okay, so kanina 30 meters tayo, no? 30 meters tayo, no? So ngayon gagamit tayo ng 50 meters. So tingnan natin kung saan siya aabot, no? Kanina, yung signal level natin dito is hanggang dito lang, no? Yan. So para meron tayong ano. So meron tayong nasa 3.05 kilometers lang. Okay, so pagka tinaas natin ng 50 meters yung ating mga antennas, so what will happen, ano? What will happen? So let's do a simulation again. Yan. Yan. So medyo lumaki yung coverage natin, right? Lumaki yung coverage natin ng up to. So kanina nandito tayo. So umabot siya ng konti sa ano, no? Umabot siya ng it reaches from 3.05, so umabot siya ng around 3.7. So nagkaroon tayo ng additional 500 meters, no, na dagdag sa coverage. So sometimes you just need to check that. We don't need a too high antenna, no, masyado mataas na antenna, but we just want to optimize the parameters, okay, nung ating antenna. So let's get it back to 30 meters, no, kasi kapag 50 meters yan, masyado mataas. And then merong corresponding cost if we go for a higher tower, no? Tapos hindi naman ganun kalaki yung magiging benefit ng ating signal coverage. So it's a balance of budgeting, no? And cost para dun sa ating design. And then ngayon ang nangyayari, yung mga antennas natin is naka 0 degree yung kanyang tilt. So gagawa natin to ng 4 degree na tilt. Iyuyuko natin yung antennas natin. Okay? So iyuyuko natin yan. Okay? So what do you mean by iyuyuko, sir, no? When we say iyuyuko, naka-tilt na ganyan, ano? Naka-tilt na ganyan yung ating mga antennas. Kanina, naka-tilt siya ng 90 degrees. Nakaganyan siya. Ayan, kaya naka-zero yan. So ngayon, ang gagawin natin, iyuyuko natin siya. So kaya naka 90 degrees siya, naka 0 degrees siya. So ngayon, ang gagawin natin, ititilt natin siya. Yan, titilt natin dito ng 4 degrees. Yan, 4 degrees. So nakayuko na ngayon yung antenna mo, nakaganyan na. So kanina naka ano siya, no, naka 0. So gagawin natin, iyuyuko natin yung antennas natin ng 4 degrees. Yan, nakatilt na siya ng 4 degrees. So just check, no, what will be the effect kapag tiyuko natin yung mga antennas natin. So let's check kapag niyuko natin yung antennas natin ng 4 degrees. Ayan. So mas lumiit siya, and then nakita niyo mas naging concentrated yung ating signal level, no? Yung ating mga signal level. Yan. So this one way, no, kung paano natin siya gagawin, no, yung ating um um delete ko lang to, yung ating site, no. So from this, you can see na we can build another site, no. So we can build another site. Okay, so if we build another site, create a base station, so we will have we can just duplicate, no, yung isang site, no. Okay. Pagka nag-duplicate tayo, so ang gagawin lang natin, punta tayo dito. Okay, so there's a copy of the IORA already. So ang gagawin natin, ilalagay natin yan dito sa isang area dito, and then we will move it. Yan. So meron na tayo isang site, and then probably dito sa dulo, we'll have another site here. Okay, maglagay tayo dito. Okay. Mag-create tayo dito ng isa pang site. Create a new base station. Okay, create pa tayo ng isang base station dito. Yan. So maganda lang tayo ng isa pa. Yan. So meron tayo isang base station dito. Meron tayo isang base station dito. And then dapat copy natin eh. Okay. Ayan. So pagka tinignan niya, meron na tayong 3 cell sites, no? And then magtayo pa tayo ng isang cell site dito. Yan. Yan, nagtayo tayo ng isa pang cell site. So meron na tayong 4 na cell site sa area. Okay, so but before that, we just need to check, no, ano yung power niyan, no? So ito, ang laki nito, 0.03 dapat. Okay, so dapat pareha siya ng power. Yan. So kung naka 0.03 yan, dapat ito 0.03 din. Okay, so ayusin lang natin yung power na para at least medyo may sanity dun sa ating dun sa ating initial assessment. Initial assessment lang to, hindi pa to detailed, no? So tinitingnan lang natin, no? Ina-assume pa lang natin. Yan. Para at least nagkakaroon kayo ng idea paano natin siya ginagawa. And then we'll do the simulation. Once we do the simulation, makikita niyo yung impact ng 4 na cell site. Kaya ba natin ang 4 na cell site? I-cover yung isang area. Okay? You get this point? So now we can easily check kung ilang cell sites ba talaga ang kailangan natin. Do we need 4 cell sites? Do we need 1 cell site? Okay, so in this time, baka gusto nating palakasin pa yung cell site. If you want to have a blue signal here, so maglagay pa tayo ng isang cell site here. Okay, lagay pa tayo ng isang cell site dyan. Tapos, ayusin lang natin yung parameter natin. Gawin lang natin 0.3 para pare-parehas yung power. Okay. Some power. Okay, and then simulate. So we can simulate, no? Yeah. So pag na-simulate natin yan, makikita niyo yung impact nung pang-5 cell site. Okay? So, so kapag 5 pala yung cell site natin, okay pala, no? So meron akong area dito na gusto ko pang lagyan, no? So you can check, no, kung gusto pa nating lagyan siya o hindi. So now you can see here na ano yung impact, no, ng isang wireless network coverage dun sa isang area. Ito yung pre natin and then yung post natin. So nakita niyo dito na ano yung impact, no? Meron kang signal. Okay, ito wala kang signal initially, tapos meron kang signal. Okay, so ganyan yung effect ng isang wireless communication system. So that's why ito yung advantage, no, kapag meron kang cellular connectivity compared sa isang Wi-Fi connectivity lang. So you can just deploy like this, no. Of course, there's a difference in cost, but we just need to balance and then check no kung ano yung mas feasible na solution sa area. Okay? So I believe I hope you learn something or you get some insights no on this one, on how do we do a coverage simulation or assessment no. So you can do this also in exercises, especially if you're assessing signal level in your areas. Okay, if you want to have some improvement in your areas, you can also do some assessment like this. And here in Asia Open Academy, we are teaching this kind of skills sa radio access network, 5G, and then you can learn this, no? That's why we are encouraging you to become one of the partners of Asia Open RAN Academy, especially if you belong to a university or college and you want to impart this kind of skill set and knowledge to your students, and also for you, no? So that you can also build skills, no? Upskilling, no? Your current status. Okay?